Hello everyone, welcome to this second day of data science masterclass with Python. So here in the session, we are going to learn Python for data analytics, like how we are using Python, and we have the two main pillars of data analysis, like it's which is nothing but NumPy and Pandas. So in the session, we are going to explore how Python helps us to analyze the data efficiently using the two powerful libraries, NumPy and Pandas. So whether you are a beginner or already familiar with the Python, so these tools making you to work with a large number of data set extremely easy. So for example, instead of writing the long loops to calculate the averages or the totals, NumPy where it can do it instantly with a single function. So Pandas, which helps us to work with the table of the data like Excel, but with more flexibility and more speed. So by the end of the session, you will understand how these libraries simplify the real world analysis, the task across the domains like education, e-commerce, and the businesses. So here we have the introduction to Python for data analytics. So Python has become a more one of the most popular language for data analysis due to its simplicity, readability, and the vast ecosystem of the libraries. So in this session, we will explore how this Python helps us to clean the data, transform it, or extract the insights. So even someone new to the programming can start analyzing data set within the minutes. So for example, if you wanted to download a CSV file of a student marks, Python can helps you to find the averages, highest scores, or missing values quickly. So the goal of this session is to show you that how the Python acts as a bridge between raw data and meaningful insights. So preparing you for the real world analytics works. It's my huge goal, right? So why Python for data analysis? So the Python, which is widely chosen for data analysis because it is easy to learn and has a rich set of libraries, right? So it is simple. It has a simple syntax, and makes a complex task feel straightforward. So with libraries like NumPy and Pandas, we can load the data set, clean it, and we can calculate the statistics, visualize the results efficiently. So for example, instead of manually calculating a class averages, a single NumPy function can do it, and it can compute it instantly. So Python also integrates well with the machine learning and visualization libraries, making it ideal for the data projects from start to finish it, right? Uh, the open source community, which is completely continuously updating and supporting it, so ensuring it powerful tools for the learners and the professionals. Here we have the overview of NumPy and Pandas. NumPy, which gives us the fast numerical operations using the multidimensional arrays, which are the essential for the computations like statistics or matrix calculations, and the pandas on the other hand, like which provides the data structured data through the data frames, making it more easy to understand and handle the tables, similar to the Excel sheet, like far more powerful, right? So when used together, NumPy handles the performance heavy tasks, while the Pandas, which offers the clean and intuitive data manipulations. So, for example, if you have a data set of the students with the marks in the multiple subjects, right? The Pandas, which can load and filter the tables, while the NumPy can compute it, the mean or the standard deviation across the subject instantly, right? So this combination forms the backbone of the Python data analysis. So here we have the NumPy fundamentals. So NumPy, which is a library which builds for the fast numerical calculations in the data analysis, we often work with the large number of data or the large number of arrays of the values, such as marks, sensor readings, or sales figures. NumPy arrays, which allows you to store the such data effectively, right? For example, if we wanted to represent the marks of 100 students in three subjects, NumPy array, which can handle this in a structured and optimized way, right? So the NumPy also supports the vectorized operations, meanings where you can add subtract or do any kind of arithmetic operations or modify the entire array within one command, right? So understanding these basics is very much crucial because NumPy powers many ML and scientific computing tasks behind the scenes. So array and array operations. So the NumPy array are the homogeneous, meaning all the elements having the same data type, helping the Python store and process them efficiently. So where we can create the array using the functions like np.array, np.zeros, or np.arrange. For example, np.arrange where we can use it for targeting the range between the 1 to 10. For example, where we can create the number from 1 to 10 instantly. So vectorized operation which allows us to performing the calculations on entire arrays without writing any loops. For instance, if we want to add bonus marks of 5 to every student's course, a simple array, uh, it can do the plus 5. So this makes the numerical task faster and more readable, especially when dealing with the large data set. So indexing and slicing. So this indexing and slicing which helps us to extract the specific element rows or the columns from the arrays. For example, if we have an array of 100 student marks, slicing marks up to 0 is to 10, so which retrieves the first topmost top 10 records, right? So the reshaping lets us change the dimension of an array without altering the data. For instance, converting a one-dimensional array of 12 elements into 3 cross 4 matrices, right? So these operations are the essential when preparing the data for machine learning models, which often expects specific input shapes. So understanding indexing, slicing, and reshaping, which gives you the better control over the large data sets and speeds up the pre-processing workflow. So here we have the vectorized operation and the broadcasting. So vectorized operations, which enables the fast mathematical calculations across the entire array without using any loops. So for example, multiplying an array of marks by 1.1 increases all the marks by 10 percentage instantly. So for broadcasting, which allows the NumPy to perform the operations between arrays of different shapes. For instance, adding an one dimension array, which is representing the subject wise bonus marks to a two-dimension array of student scores automatically applies the bonuses correctly. So these features makes the NumPy extremely flexible, helping us to perform the task like discount calculations, normalization, or image data manipulation efficiently. So understanding the vectorization and the broadcasting helps us to write the cleaner, faster, and more Pythonic data analysis code. Statistical functions using the NumPy. So the NumPy, which provides the built-in functions like mean, median, standard deviation, and even variance for quick data statistical analysis. So for example, if you have the marks across the student subjects, right? You can use the np.mean of the marks where you can instantly compute the averages. So these operations are the optimized for the speed and can handle the large data set effortlessly. And the statistical functions are the essential for the exploratory data analysis, helping you to understand the trends, variations, and the patterns before applying machine learning or advanced model techniques. So whether you are analyzing the student scores or sales numbers or sensor readings, NumPy which simplifies the process and allows you to focus more on the insights rather than manual computation. pandas for data analysis. So till now we have we understood what are the the benefits of using NumPy. Here, furthermore, we will be at going through this concept called of pandas. So pandas, which is one of the most powerful tool in Python for working with the structured data, unlike NumPy, which focuses on the numerical arrays. The pandas, which provides a data frame that resembles the Excel tables, but with a far greater flexibility. With pandas, where we can load the data, where we can filter the rows, and we can handle the missing values and extract the meaningful insights look quickly. So for example, if you have a CSV file of a student information, pandas can read it using the read.csv command, and allows the operations like filtering the students with the marks above 50%. So pandas is essential for the real world analytics because more data set comes in the data table format, and the data frame which makes them easy to manipulate it. Series and data frames. So a panda series is like a single column of a data with labels. So while a data frame is a complete full table with rows and columns. So series which allows quick to access the values by indexing, and the data frames which helps us to combine the multiple series. For example, like student names. The student names might form a series, and marks across the subjects can be added as a separate column to form a data frame. So likewise, with the methods like indexing, slicing, and apply, where we can manipulate the data, where it can become as a more intuitive. So whether you wanted to extract the top performance or compute the averages in a data set, data frame which provides a clean and powerful way to analyze the structured information efficiently. Reading and writing CSV files, CSV and Excel files. So obviously, like we can use the read underscore CSV function and to upload the data CSV files. We can replace the CSV into Excel file to upload the Excel data, right? So here next, we have the data selection and filtering and sorting techniques. So pandas, which provides a powerful methods like a lock for label-based selection, and the ilock, which is used for the index-based selections. So this helps us to retrieve the specific rows and columns easily, right? The filtering, which allows us to extract the based on the conditions, say for example selecting the students who scored the above 80 percentage, right? And sorting with functions like sort values helps us to order the data by marks, names, or any field. So these operations are the essential for organizing and analyzing the data set in a structured way. So whether you are filtering the low performers or sorting the sales data by price, pandas, where it can makes the data exploration intuitive and efficient. So gives you which giving you the precise control over the large data set. So here we have some of the techniques how to handle the missing value. So this is the most important concept in a data science. Like we will be dealing with the more number of missing values in a large number of business data. So obviously we should know what are the techniques where we can use it to handle the missing values, right? So the missing values can affect your analysis and model performance, obviously. So the pandas, which provides functions called fill NA to replace the missing values with the values like a mean, median, or a constants, right? So for example, if a student's marks are missing, right? So we can use the fill NA, we can use the mean, average, can substitute the averages, right? So obviously that's not a good technique, but when it comes to the business world, a real use case, we should have the talk with the client and we should get the requirement. You can give some suggestions like whether I can use the mean or whether I can use the random values. So then and there, like we can get some clarity, and where we can replace the missing values. So handling the missing values ensures that a clean data set, first of all, and which is crucial for the reliable insights and the machine learning accuracy. And this steps no like is always done early in the pre-processing and helping and maintain the quality and integrity of your analysis. So group by operations and aggregations. So group by is in pandas, which allows us to group the data based on the certain columns and compute the summary statistics. For example, if you have the sales data, you can group by the product category and calculate the total sales using the NumPy. So we will be going through this in a demo in a very deeper, like how to use the NumPy functions and how to use the attributes, how to use the how to fill the missing values using some more techniques, right? So let's undergo this theory part first of all, and we can dive into the demo in very deeper, right? So this group by functions, which is especially useful and powerful in a business analytics, where we can summarize the large number of data, is essential, right? So group by transforms the raw data, detailed data into meaningful insights. So making pattern easier to understand and interpret it. So here we have the next slide that how to use the merging, joining, and concatenations. So pandas, which allows to combine the data set efficiently using the merge, join, and concat operations. If you have the one data set containing student names and another containing their marks, merging them creates a complete data set for analysis. So merge works like a SQL joins where you can use the inner join, left, right, or outer join, and this concatenate, which helps to stack data set vertically or horizontally. So these operations are the crucial when working with the real world data coming from multiple sources. For example, uh, merging customer informations with the uh, transaction details, which gives you the full complete picture for a deeper analysis. So the understanding these techniques, which enables you to build a comprehensive data set for accurate insights. So NumPy analysis. So here we have some of the diagrams for example, like for to getting you to understand more, more informatively. So in the slide, we are looking at the statistical measures computed using the NumPy, like a mean, median, and mode. So these helps us to understand the distribution of the values. For example, if this data set represents student scores, the mean, which tells us the average performances, the mean shows us the middle score, and the standard deviation, which indicates how spread out the scores are, right? So these visualizations like a histogram and the box plot, which helps us to see the patterns such as the skewness of the data and the clustering of the data and outliers. So let me tell you that what is skewness, what is clusterings, and what is outliers. So this combination of the numerical and the visual analysis gives you the more complete understanding of the data before deeper explorations, right? So here we have the sales trend analysis. So this slide, which shows you the line chart representing the monthly sales trend using the pandas and the matplotlib, we did it. So like a line chart, which helps us the visualize how value changes the over time. For example, if sales increases steadily over the months, the line chart will show an upward trend. And pandas, which allows us to plot directly from the data frames, making it a visualization simple. And such as chart helps the businesses to identify seasonal patterns, growth periods, or sudden drops. So understanding the time-based trends is essential for the forecasting and decision making. So you can apply similar techniques to visualize student attendance, website traffic, or any time series dataset. So pandas pie chart. this is the pandas pie chart, like where we can get to know that the data propositions of in a data set. So here we visualize the product category distribution using the pie chart. The pie chart are very much useful for understanding the proportion within the data set. For instance, if this represent the e-commerce categories, so where we can able to see which category contributes the most number of the sales. So the pandas with which is integrates with the matplotlib, allowing us to create a such chart with simple commands like dfplot.py, where we while the the pie chart are visually appealing. They are the best to use it when showing the limited categories. So this visualizations which allows us to quickly understand the dominance of or balance among the categories, and supporting the decisions like inventory planning or marketing focus areas. So here we have some of the case studies where it's very much important to understand the case studies first before getting into the business data analysis, right? So in this case study, we analyze the monthly e-commerce sales data. First, we load the data set first, and we will be inspecting the missing values to ensure the data quality. And next, we will clean the missing data by filling them with the mean, right? It's not like a mean, like we can either fill with the median or something else, right? So next we will cleaning up the missing data by filling them with the mean, which prevents the errors during the calculations. So we then come to the summary, the statistics such as mean, median, or the standard deviation to understand the performances. So finally, we visualize the sales trends using the pandas and matplotlib, helping us to understand and to spot the growth of the patterns or the dips. So here this workflow, which reflects the real world analytics, where we can load the data set and clean it and analyze it, and we can visualize it for furthermore, right? So mastering this pipeline prepares you for the practical data analysis task. So here we have the next case study, that the student performance analysis. So in this case study, like where we can analyze the student marks across the subjects. First, we will be loading the data set and checking for the missing values if the marks are missing. So where we can handle them using the appropriate methods, like filling with the averages. Next, we will be computing with overall the subject-wise averages using NumPy or Pandas. Finally, we will be visualizing the performance using the bar charts, making it easy to compare the subjects. For example, if math scores are consistently lower, the teacher can focus more on that subject, where this workflow mirrors the real world, the academic analytics, and where it can helpful to identify the learning patterns in classrooms or the institutions. So as a data analyst or the data scientist, it's our responsibility to give the business findings to the client, right? So here we have some of the data pre-processing steps before getting into the visualizations. So pre-processing, it's very much crucial for ensuring the clean and reliable data set. We start by removing the duplicates first. So each student, it's counted only once, right? So next, we will be handling the missing values, either filling them or dropping the row completely. So it's one of the most the important thing to check with the client if you are not handling with the client in a business. So whether if you are finding any missing values in the large number of data set, you can proceed some of the techniques. We can suggest some of the techniques. Okay, so these are all the techniques that I'm going to undergo, that I can use it on this data set, like whether I can do it with the mean, filling with the mean, or we can fill with the random values, or either I can delete the complete row or the complete column, which having a more number of a data set, it's getting missed, right? So here we have the encoding techniques. So encoding the categorical data, which converts the text fields into numerical formats for the machine learning purposes. So obviously we know that the machines knows zeros and ones. So it's very much useful, like zeros and numbers, zero ones and numbers, right? Either. So the machine learning, we will not be giving the complete text. We will be converting the categorical data, like say for example, if you are getting the feedbacks, right? So in that feedback, we'll be getting very good, good, average, low, and very low, right? So these are all the categorical variables where we can convert these variables into numbers: 5, 4, 3, 2, 1. We can rank it up according to that, um, uh, the propositions. So where, for example, converting the male, female to zeros and ones. So male as a one, zeros as a zero, or female as a one, or female as a zero. So enables these algorithms to understand the data. So this pre-processing builds a strong foundations for the accurate analysis and the model building. So here we have the the code snippets of the data pre-processing steps. So first, what we are doing is that we will be first we'll be reading the data set. We'll be loading the data set using this function, and we'll be removing the duplicates. For removing the duplicates, we'll be using a df dot drop duplicates. And for mixing up the values, here we have some of the techniques. So the first, we'll be handling the columns, first numerical columns, so which number, which includes the numbers. And after that, where if you wanted to analyze the categorical variables, where we can use the excluding the numbers, whether it is telling that excluding the numbers, it should analyze the columns where it has the words. So if it is having the missing values, it will be identifying it. So df number columns, which is telling you that to fill up the the missing values, where it is a median value, right? Or else, like if it is a categorical columns having the missing values, we can fill it out with the unknown, it is an unknown variable, right? And we will be normalizing with some of the techniques, normalizing the data. So here, before getting into this normalization, I need to give you the prior explanation of the outliers. So this outliers, which is nothing but it's an odd man out, right? So if you are handling with data set, the unusual data point, which is called as an outlier, right? So for example, if you are calculating the heights in a classroom, right? Obviously the classroom, the average height will be around 160 to 170 centimeters. So what if the height of one data point, one person, one student, it's around 300 centimeters, or obviously it's an outlier. So these 300 centimeters, which will be treated as an outlier, and it will be removed, or it will be yeah, it will be removed, right? So why? Because it's obviously it might be in a high possibility to be a wrong value, right? So while giving it to the machine learning, the machine would predict, will proceed wrong values, right? So for that case, we will be treating that outlier, and we'll be reducing that outlier into the smaller brackets and the ranges, right? So here we are doing this encoding, the categorical column. So we are taking that categorical column, and we'll be encoding it. And after that, we'll be doing that sanity checks. So whether it is good to go for the next proceeding for the visualization, and for the analyzing the business findings. So here we have the NumPy statistics, some of the techniques, the alternative stats with the NumPy. So here we will be analyzing the data set, right? So sorry. So this NumPy, which is very much useful to analyze the mean of the data set, mean scores, like what is the average scores of a correct classroom, and how much it is getting deviated, whether it is getting positively deviating, or obviously the deviations will be on the negative and positive, right? So how much it is getting deviated from the average, right? So this standard scores, and which analyzes the standard deviation, and we will be printing it, right? And after this pre-processing, visualization, which helps us to understand how the data behaves. The box plots shows us the scores distribution for this each subject, highlighting the median, spread and the potential outliers. For example, if one of the subjects box is much shorter, it indicates the list variations among the students. So the histogram which displays the distribution of the composite scores, helping us to see the whether the data set is skewed or balanced. So such visualization are the essential in understanding the data quality and student performance patterns. So they reveal the trends that might not be obvious in a raw numbers, guiding further analysis or academic interventions. So this visualizations after the processing, we'll be doing that correlation and summary, right? So this, the slide depicts that displays correlation heat maps and bar chart or of average scores. So this correlation which helps us to understand the relationship between the subjects. So for more example, if a math and the science scores are strongly correlated. So here, it is showing that it's in zero point 0.1, right? Sorry, 1.00, right? So obviously, it is having a high correlation. So whether it is in zero or it's in a minus, we can treat it as a less correlated or a medium correlated. So the bar chart which highlights high performance in each subject. So helping us to identify the strengths or the weaknesses of each subjects, right? So these visual insights are the valuable for the educators to design the targeted improvement strategies. So understanding the correlations are also guides the future data modeling decisions in predictive analytics. So here we have the conclusion and the best practices, and after this, before getting into this, we'll be having the demo, right? So let's get into the demo first. So let me open VS Code, and here let me open the folder and let me create a new folder for it, right? So in this masterclass, let me create a new folder called day2, and let me name it as a demo, right? So here, where you can use either Python notebook or you can use the Python files. Okay, let's now start creating the project. Let's get into the demo now. So before getting to the demo, I would like to create a file. So let me name this file as a demo. For getting the uh, Python notebook, we need to use this extension IPYNB. So yeah. So once getting that, we should create a code space. So let's create a code block here. So before continuing to that, I would like to import the necessary packages. So I would like to import pandas as PD, import NumPy as MP, and import matplotlib pyplot as PLT. So once we upload all this files, let's confirm, yeah, it's got cleared. So after this, uh, So we have to import the different files, right? So I have generated a clean, realistic student performance data set. So with a few intentional issues, I made it right for the teaching purpose. So let's import those two files. So those two files are the same files but in the different formats. So let's import it. So the first thing is that I would like to import the uh, read.csv. So let me import it. So for this, I would like to name it as a df pd.read csv. So we have to replace this as into the real code path. Sorry, real dataset path. Right. So let me choose this. Let's copy as path. Let me paste it here and just remove the extra quotation marks, right? So let me import it. And once we, get this tick sign and let's confirm this by using df head parenthesis. Yeah. So here it is, telling you that the data got imported and you have, have this data for the first 5 rows. So once you wanted to see for the first 5 rows, you can, leave it empty. So if you wanted to check for the specific 10 rows, right? So just enter 10 and run it again, right? So you will get the top 10 rows. So it is, from 0th row to 9th row. So totally 10, right? So let's import the another read Excel, right? So for this, what you have to do, we have to replace this read CSV as read underscore Excel, right? So let me import with the same name, same variable, right? Read underscore Excel, right? So once it is done, let me go and copy paste it. Let's remove the extra quotations. So once it is done, just check it. Yeah. So df dot head top 5. Yeah, once it is done. So here, like here we can see the data shape data set shape. So if you want to see the data set shape, like how much rows and how much columns we have, we can check it by using the shape function, right? The shape attribute. So here we have, it is saying that we have 38 rows and 38 columns, sorry, 38 rows and 10 columns, right? So after this, we have to do some statistics and vectorization. So let's get into, the utilization of the NumPy, right? So let's create a new code block and import NumPy as MP. So after this, what we are going to do is that we are just going to extract only the score columns, right? The score columns. So here we have this 3 columns, right? These 3 columns, which is defining you that the students got who scored in each subjects. So let's extract that score columns, right? So we are just scoring, we are just storing all the the columns into one particular variable. It's called scores. So I'm just using the slicings, which is nothing but it's you know the square brackets for doing it, right? So we have to use for the two set of square brackets. Why? Because we once once we are doing the index more than one variable, we have to use the two square brackets, right? So I'm just targeting the max. Yeah, math. Yeah, just try to use the same spelling, same naming conventions of what we have in the column, right? And English. So let's try to convert into NumPy. Yeah, once it is done, just check it, like how the shape it is, shape of the data, right? So the shape of the data, oops, I just wanted to know the shape. So to know the shape of this data, like we have to give the variable and we have to use this attribute for it, right? So once it is done, so it is telling that we have selected the three columns and 38 rows, right? So our data set is clear. And if you wanted to do the statistics, like the average score from each subjects, we can get it, right? So let's use the uh, mean function to get it, right? So I just wanted to know the mean of each subject. So for selecting the each and every subjects, we have to use this slicing. So I'm just selecting the each and every subjects. We don't these things first. So before printing it, what we have to do, we have to use the functions to getting out the mean. So we are just storing this column underscore means, and we are using this function to get all the uh, you know uh, the averages of each and every subjects. So let's generate. Okay, so we have just try NaN mean. Oops, okay. So here we forgot to give the variable name, right? So let's give it columns underscore. So here we got it. So for each and every subject, here we got this each and every averages from each subjects, right? So here, which is telling you that the students scored in each subject. So these are all the average marks from each subjects. So and let's do the data cleaning. Data cleaning, which is very much useful and which is very much necessary to do it before getting into the projects, right? So let's name this as clean for analysis. Let me, oops, I selected a wrong. So here we can, use this markdown cell to create the partitions, right? So here we can, do the data cleaning. We can, check for null values. We can check for, the wrong data. We can check the outliers. We can, fill that missing values using mean and median, anything. So let's clean the data, right? So I'm just naming this variable as a data clean. So before data cleaning, I just wanted to take a copy of the data. So I'm just doing the copy, right? So it's a best practice to take a copy of each, when you're doing the data cleaning. Why? Because we should not, directly handle the raw data where it can be manipulated, right? So before getting into that, we have to do the data copy and just keep this second copy of the first raw data, right? And what we are going to do is that we are just going to fill the numeric null values with the median and the text values text null values with the unknown variable, right? So let's go and change this file. So I'm not sure that which is an Excel file. Let's get into that. Yeah. So here we have some of the values, right? So here what I'm going to do is that let's keep this maths and the science. We have some missing values, but what I'm going to do, uh, I'm going to remove Ria name, right? Ria, and here some of the names got missed. Okay, so let's keep as such, right? So let's get into it. So what we are going to do, we are going to do the data cleaning. We are going to find the missing values. So let's go for the numerical columns. We are just targeting the numerical columns where we have this numbers first. So let's find the numerical values in the numbers. So here we have some of the numerical null values. So let's go and fill it with the median, right? So here we are going to select only the math and science. Okay, so it's enough. And so what we are going to do, we are just going to clean this data with we have going to fill the number numerical null values with the median data, right? So just name it as a df clean numerical columns. Oops. Okay, so df underscore clean. We are just using this numerical columns, right? We are just going to apply the lambda functions. So lambda, it's nothing but it's an anonymous function where we can use it for the temporary purpose to do this repeated, repeating process. So let's use lambda. So here we are going to, ingest with the median, right? So let's say run. So it got run. So let's say to call, to check with the data clean dot head. So here you can just see the comparison. So here with the amin, with the null values, here it has got ingested that we have ingested with the median data. You can just check with the the calculations. I will send you these data set into the description and in the group as well. So if you are following JAI learn, you can able to get all the the updated sessions and masterclass that we are conducting, right? So please subscribe and share to your friends, ask them to subscribe, so they will also get the updates as soon as possible that I'm releasing, right? So let's get into the the next part, that we are going to replace the null values that we have it in the uh, you know that we have it in uh, apart from that numerical values. So we will just target the names and we will ingest the null values as a unknown, right? So let's get and name it as a data clean, and what we are going to do, we are just going to target the name column, df underscore clean, and we are going to target the name, and we are just asking it to fill with the unknown, right? So once it is done, just call it. So here just call 38 rows. So we can able to get, so here it got filled as an unknown. So likewise, we have to do the data cleaning. So these are all the minimal steps that we are doing it. But in when it comes to the project, we have to do the intensive no the data cleaning. So let's get into the fourth part, which is no nothing but visualization, right? So let's get into the visualization. Uh, okay. So let's import matplotlib. Matplotlib.pyplot as PLT. So what we are going to do is that we are just going to analyze, we are just going to do the demographic, just a demographic, the diagrams. We are just going to analyze the average of each subject scored by the each student, and what else we can do? We can use that what we have generated. So here we got this, you know, the average scores by the subject. So likewise, we can generate each and every diagrams. So let's create it. So what we are going to do, we have to use some of the styles which is available in my Matplotlib. So let's use those styles. I have some of the styles listed. So let's use Seaborn Vivo 8 white grid. So this is my favorite, the general the style that we can use it, right? So I'm going to use Seaborn V0 underscore 8 white grid. So after this, what we can do, we can use the command function to name it as average score per subject. Yeah. So here we got the functions. So here, which is telling you that we have to identify the average of each subject, and we are just going to compare with the marks, right? So let's name these axes as a the kind of a bar chart we need, and we can convert that into the color palettes. So let's do it, right? So let's say that we need a means plot and the kind of bar chart. And here it is telling you that the sky blue and salmon and the light green. Yeah, that's fine. So next we have to generate the title of the visualization. So let's name this title as average scores per subject. And next is we have to set the y label that what we can do, we can call it as a average, and x label what we can call it as a subject, right? So let's name this y label as average scores, and we can yeah, call this as x label set x label as a subjects, right? So once it is done, we can do the PLT show. So this PLT show, it's nothing but for doing this commenting, for getting the output for each program, we used to give the print statements. So instead of print statements to get this diagrams, we have visualizations, we have to use this PLT dot show. So simply saying, yeah. Uh, so it is showing you that means plot and the kind of a bar. Yeah, that's good. So one second. So it's a space. Let's leave a space. You're not getting it. So here, what is the thing? Yeah, you just read access object, no attribute, x underscore label. Yeah, so here we just added one more underscore. That's why it's not giving it. So let's create it. So here we got the, the visuals that it is telling you that the average math score it's around about the 70 percentage and the 72 and 73 percentage of each subjects, right? So here we got these visuals. So that's all for today's session, and just try these codes in your daily workflows and the daily practice. So then only you will be getting the much more grip on the code, right? So I will share these codes into the group, and you can access it. And I will be sharing the community group and the learning group of a WhatsApp in the description. So please join after watching this video. So let's wait for the next announcement of the next masterclass. So until then, this is Jay Surya. I'm signing off. Bye. Thank you.